We introduced computational hydrographic printing, a new method for physically decorating 3D surfaces with user-customized color textures. Hydrographic printing is a widely used technology in mass production for transferring repeated color patterns to a 3D surface. It uses a PVA film with printed color patterns put on top of water. Then an activator chemical is sprayed on the film, softening the color film to make it easily stretchable. Next, a physical object is slowly dipped into the water through the floating film. Once touching the object, the film gets stretched, wraps the object's surface, and adheres there. Throughout, the color ink printed on the PVA film gets transferred to the surface. A fundamental limitation of hydrographic printing is that it is almost impossible to precisely align a color pattern to the object surface, because the object stretches the color film. With complex surfaces, the stretch can be severe and even tear the film apart. Consequently, current hydrographic printing is limited to transferring repetitive color patterns as shown in these examples. Our computational hydrographic printing enables precise alignment of surface textures to complex 3D surfaces. We build a controlled hydrographic printing system using off-the-shelf hardware. In this system, the object to be colored is held by a gripper connected at one end of a vertically placed aluminum rod. Driven by a linear motor, the rod can be moved upward or downward at a constant speed. A 3D vision system is integrated to measure the location and orientation of the object with respect to the color film. Our major contribution is a computational model to simulate color film distortion during hydrographic immersion. Our simulation model creates a texture map between the colors on the film and the surface locations where they are transferred to. We use this map to complete a color image for printing on the PVA film. After that, we print the film with a conventional inkjet printer, place it on the water, and finally conduct the physical hydrographic printing. Here we compare the digital model and the colored physical object generated using our method. Our method can be extended to handle complex objects by dipping the object multiple times, each with a different orientation. This is an example with 3 immersions. Let's see more results. Here is a zebra colored with 2 immersions. We first show the virtual simulation and then the colored result. You can see our method generates precise alignment of surface textures to a 3D surface. Here's a bunny with complex surface textures. Hydrographic printing can be applied to various materials including metal, plastic, and porcelain. In this example, a porcelain cup is first scanned to get its 3D model, which is then texture mapped by an artist. Finally, the cup is colored using our method. This is a statue object. This example is a globe with an earth texture produced with a single immersion. Thank you.